They change sign. It's hard to explain what that means. Subtracting 9 from 9 and y from both sides. Makes sense. Here we're going to subtract 2y and 8 from both sides. And your layout won't always be the way you wanted it. You know, you might have, I forgot there and I pushed my equation over to the right a bit much, and don't let that bother you. You have to be flexible. The bottom one, am I recording? Yeah. The bottom one I subtract 2y, bringing him back, and I subtract 8. Okay. And I'm going to try, maybe this is a good place to put it, half naught into this. Okay, 4 times a half minus naught. Always use your brackets while you're solving, because you'll have no clue what you did later if you make a mistake if you don't. Equals negative 9. Okay, well that's nonsense. Oh, I mixed up my questions. That was from the last question. And you can see an advantage here already. I have my brackets and I can just sub the new values in. You can see another advantage. So actually it was minus 2, 1 I wanted to put there. Okay, which is minus 8 minus 1, which is indeed equal to negative 9. Okay, just put a tick. I think it's the quickest is a tick. And then maybe we'll mix the two systems and put not equals when we know it's not equals. Over here, 3 times the subbing of negative 2 minus 2 times the substitution of 1. Even me saying the substitution of is now becoming linked and connected with the bracket. Squiggle negative 8. 3 times negative 2 is negative 6, negative 2, oh, this is good, we have negative 8, okay? So in question 14, this is true, in question 14 the answer was A. And we move on to 15. Well, we're going to do them all, right? So I don't even have to remind myself where we're going to. So the next thing is we're going to do question 15. And the only thing I need to hang on to is my table over there in the top right. So question 15. Surprisingly, this is back in the form we'd like it to be in. Which is nice. So it makes it a shorter question. So x plus 2y equals 1 and 2x minus 3y equals 16 equals, be careful of the sign. Very common there to kind of say it in your head, and then now you have an advantage with your script in real exams, but because we're teaching in pandemic classes, the advantage is removed and you need to transfer. It's an old skill, you don't have to do as much anymore. It's an important skill nevertheless to transfer from your phone or your computer screen to your copybook. So it's a pandemic skill, if I like. Okay, so we've written down our system of two equations. And we are now in question 15 trying out how its 7 and negative 3 look. So we would get 7 as a substitute and negative 3 as a substitute squiggled to 1. We would get 7 take 6 is indeed equal to 1. True. Okay. And we go here and go 2 times the substitution of 7 minus 3 times the substitution of negative 3. Doesn't look good, or it does it? 14 plus 9 is not 60. And it ain't A. Okay. 14 plus 9 is not 16. We're holding on to this and we're bringing in the next candidate solution point, which is 5, -2. So we're going with x is 5 being substituted plus 2 times -2 equals 1, and that's true. Okay, I'm going to be able to use a bit of flexibility. I've stretched myself over there a bit, so I'm going to put this here. 2 times 5, -3 times -2, separated from 16, I think we're looking good here. 2 5s is 10, minus by minus is plus, 3 2s is 6, is indeed equal to 16. Now are both of them true? We have a true on this. This is our second candidate, B. 5 -2, and we have a true on this. We've got the two trues that we need. Okay, so we're going to question 15. It was B. Give you a lot of these to do, but if we can't do these, really, we're gonna. This is like verifying you got the right answer in the question. And if we can't verify we got the right answer in the question, sure, we might as well throw our hat at it. So you won't generally be spending a lot of time trying to verify non-correct solutions. Well, hopefully you won't be getting them wrong and then finding out you got them wrong. But if you do, that's okay, because at least you're finding your mistake during the exam. So in question 16, we're back, guys, if you look at question 16, I'm going to write it up now. We're back where the question is given in standard explicit form. That means it equals the constant is on the right hand side, not the other way, the implicit form where y equals is the way the equation is given. So in a standard explicit form, I'm going to split it to a left-right situation. 5x plus 3y, and I've noticed I need a bit of extra space for the candidate points, the candidate ordered pairs of x and y. I'm going to put here. So I'm going to start nudging it out to the right. So maths is an awful lot like art, and it's like 2D design. Maybe if we're good at architecture, not because of the numbers and what they're telling us, but because of the layout. Layout's very important. Okay, so we've moved to 16, and I'm going to go 5x plus 3y equals 4, and 3x minus 2y equals 10. And my first candidate solution is the numbers 2, -2. And for the heck of it, just to write them out now, no, -5, and 5, -7. Okay, so heading into substitution. So I'm getting 10, take away 6. Is equal to 4. Happy with that. And I'm getting 3. But also all my turning in my head and everything, checking. And it's very much a kind of a tactile thing, and it's tactile for you on your notes as well, where you could use your both hands and verify that -2 there is the y value has been subbed in with a y, and I'm separated from 10 because I don't know if it's going to work or not, and it's not going to work because I have 6. Oh, it is going to work. 6 and 4 is indeed equal to 10. So the very fact that I have equals doesn't, because I'm using the squiggle system, I don't have the fact that I have equals is the same as writing true. So they've both been verified. Okay? So now we know for 16 the answer was A. in explicit form, standardized. ABA. We're going to 17. Seven of them plus 3 of them is separated from 5. Might be equals, might not be equals. 35 take 30 equals 5. Happy with that. And now 3, notice my finger is here holding on to my x and my y. 3 of them minus 2 of them. We're able to handle the integers because we're using a bracket for substitution. And we're not doing algebra. Substitution is an algebraic step. We're not doing algebra and calculation and arithmetic at the same time, ever. Okay, well, maybe later on, but for now, no. Okay? And until you're really, really competent, because that's where you'll come a cropper. Do your algebra, then do your calculation, whether you're using a calculator or not, depending on what level we're at. Okay, squiggle 12. 15 plus 20 is not equal to 12. No. Okay, so that's that one a failure. That means this is not a solution to this system. Next candidate 40. And I can use this or this. In fact, this is even helping me out even more maybe because I'm seeing just what I replace. And one more step here. Let's get rid of that. Let's not write anything there. Let's put the 4 here and a 0 here. And what I really like about this is the squiggle is valid. Okay. And let's talk about 28. And you don't need to show all your work in this case. Once you've convinced yourself that the first point doesn't work, you're good to go. Now that 28 is definitely not equal to 5. Okay? So I don't need to check that one because this one's already failed. So that's the end of him. Okay? Hope you're beginning to see how, no matter how great we think we are, no matter how we've nailed it, we're open to new ideas and improvements in the system. Okay, so that goes away, and that goes away, and we'll promote or bring it closer to -3. We're expecting this guy to, we're expecting great things now from this guy. Okay, so the 2 goes in, the -3 goes in, that's 14, -9, which is indeed equal to 5. Well, it had to be. This is all set up nicely for us. We just need to redo the substitution. Redo the alternative, another option, alternative substitution into the bracketed, if you want explicit, but I wouldn't normally say that word. It wouldn't be necessary there, so let's take it up. The bracketed standard form equation, or just standard equation. And what I mean by standard, you know the x comes first and the y comes second into the brackets, even if no one's telling you. So even if I talked about all this there and got distracted as I started telling you a sentence, redo the alternative substitution into the bracketed standard equation. Meaning if that's just code for the x comes first and the y comes second in the brackets. So I'm redoing it with my new candidate 2, -3. So I'm taking out whatever's there, and even if I had put in the correct one and I'd forgotten, it doesn't matter, take it out and relook at this. 2 and -3 must go in to my equation, even if it's a squiggle equation, in standard form, with the x term first and the y term second. So 2 should go there and -3 should go there. And as I said, we really expect this one to come up trumps because it's the last one. The question has implied one of them works. 3 2s is 6, and -2 by -3 is negative by negative is positive. 2 3s is 6. So we can confirm that that's equal to 12, and now we have a true on the right and we have a true on the left. So for 17, C is the answer. These videos are very long and you don't have to look at it all. You might gain a lot from looking at them even if you got the answers right, but you also have to think, put me on fast, on ×2 or ×3, and it'll make my voice go funny and stuff. Okay, I don't mind if you do that. So question 18. So it's in standard form.